Hey guys, welcome to R2E, and this is me Raman, and this is problem number 3.5 of Daniel Kleppner and Kolenkow. So let's try to solve this problem. So let's see what this problem says. So the problem says we have a mass M that is connected to a vertical revolving axle with two strings, like these two strings, of each length L, making an angle 45 degree with the axle as shown. Both the axle and the mass are revolving with an angular velocity omega. Gravity is directed downwards. So first thing is make the force diagram clearly. And the second thing is find the tension. All right. So, okay. I think I'll mark on this one only. Okay, so the weight is acting downward right out here, mg. And let's say there is a tension T1 and there's a tension T2 right out here. So there's an upward force. I hope it. Okay, sorry about this. I have a little trouble in drawing straight lines. I hope this time it gets straight. Yeah. So there is a that is T1, and since this is a cos, so it doesn't matter. It's T1 upon root 2, and there's a the perpendicular component right out here is T1 upon root 2, and same where here we will have T2 upon root 2, and down there again we will have T2 upon root 2. So let's try to write down the equations, and in the horizontal direction, let's say in the horizontal direction, I have my equations as T1 upon root 2 plus T2 upon root 2 equals to the centripetal force, that is m omega squared L. But since the length L is from here to here, so this will be L cos theta. Cos theta? No, L sine theta. L sine theta, that is your 45 degrees. Is your 45 degrees, and that is 1 by root 2. So this, and this cancels out. So I have one equation that goes as T1 plus T2 equals to m omega squared L. So that is equation number 1. And now let's see it in vertical direction. In vertical direction, that will be T1 upon root 2 equals to mg plus T2 upon root 2. So this implies that T1 minus of T2 equals to root 2 g. So from equation 1 and 2, I can write that T1, sorry, 2T1 equals to root 2 mg plus m omega squared L. So my tension T1 will be simply m common g upon root 2 plus omega squared L by 2. So this is my tension in the upper string. And now let's try to figure out the tension in the lower string. Okay, so what I'll do is I'll multiply the uh, equation 2 by minus 1. So that will go as minus 1. Once it's multiplied with minus 1, it will be 2T2, and it will be m omega squared L minus of root 2 mg. So that goes as T2 equals to m common omega squared L by 2 minus of g upon root 2. So with this, I am done. So I found my tension in the upper string and in the lower string. So with this, I'm done with the video. Thank you for watching the video, and see you in the next video.